I'm a teacher Ulimboka Nsijiga Masami. Welcome to Ulimboka Physics. We have a question from SERWAY&JEWETT, the exercise of chapter 35, question 55. As if that hides a precious jaw by placing on the bottom of the public swimming pool, and he places a circular raft on the surface of water direct above and centered over the jaw as shown here. We have asked it to find the maximum depth h of the pool for the jaws to remain unseen. It's either observer eyes in either sides from the circular raft on the surface of this swimming pool, trying to observe the inside of the pool. He or she can't see the image of this jaw. Let us see how this is possible. According to the diameter of the circular raft, the jaw is at the bottom vertically to the center of this circular raft, and this ray is normal. And assume we have two rays here, purple, and this is yellow. The yellow one has got a small angle from the normal rather than the purple one. Let us take a look along so that we can see if any rays can give us the image of this jaw. For a yellow one, as you take a trace close on this look of this trace of this ray, you can see it incident at point M and gets refracted away to observer I1, and then this refracted rays will be extended backwards so that form an image at a point P. You can see that the image of this refracted rays is blocked by circular raft at the point P. Therefore, the jaw won't be seen at this angle. When this purple is passing through to point N and refracted with this green ray, the extended backwards refracted rays is directly blocked by this circular raft. Therefore, even at this point, the observer can't see the image of this jaw and can notice anything that is going on. Now, when this rays is reflected at this point P to point O dash, and then gets reflected to point M dash, is refracted away to observer I dash, and this observer I dash will see an image as extended backwards to point P dash. This P dash here, there's no any image of a jaw except the image of the edge P of this circular raft. As you can see, the rays comes from this point P and form its image of edge P as P dash. Therefore, for the matter of linking this jaws in relation to angle of incidence and refracted angle, the depth P dash to N dash is equal to 0, because there is no any image of jaw here except the image of the edge P. But the whole depth N dash to O dash is just the depth of this swimming pool that is required to make sure that the jaws will remain unseen along the swimming pool, the surface of the swimming pool. Okay, let us take a look on this purple trace of the ray. This purple is incident at point P and point R, and forming a circle or a cone PRO. This cone has got the incidence angle I. According to law of reflection, this incidence angle I is the same as this one, and it also is the same as this one. for a cone S M dash O dash. Therefore, when this circular raft is floating on the surface, this P is taken on the surface and this R is taken on the surface, we can see that the circle, the radius, these two cones S, M dash and O dash and P, R and O will have the same radius and the same diameter as that of the circular raft. As you can see, their angles are the same. Therefore, these two cones are of the same magnitude. Okay. After understanding this, I try to just draw here a circle and show how this constructed refracted rays. This now refracted rays is that extended backwards is act as a constructed, so that we can link this refractive index, depth, incidence, and yes, to see how we can get this diameter, the radius, which is half the diameter. Consider the Snell laws. As you can see, the Snell laws here, the incidence is within the water and the refracted is in air media. Now we take the hypotenuse downward, and the opposite as is common for this triangle, and it's cancelled out. Then for no small angle here, we must use the Pythagoras theorem to get the hypotenuse O dash M dash and the hypotenuse P dash M dash, O dash M dash and P dash M dash. Okay, then we substitute this into the equations that is made here, and we define these sides, and now O dash N is just a depth h, and M dash N is just the opposite, that is radius, which is equal to half diameter, and the P dash N dash is just equal to apparent depth. And after take a look at it, let us see here. We know that the apparent depth is equal to 0 because there is no any image here except the image of HP. Now we remain with after putting here 0 for apparent depth, now we remain with refractive index for any media, as you can see here below. And when you have given from our questions diameter, refractive index of water is 1.333. now we are supposed to make the subject to get a relationship between H and D. Okay, as you can see here. Now after substituting the data, we'll have 1.99 when it is 1.33 refractive index, but when it is 1.333 it is equal to 2.008, that is approximately is equal to 2 meter. Thanks for watching. Please like, share, comment. Don't forget to subscribe this channel for more video like this one. Thank you.